8th grade. We are going to get into our very last example of section 4.8. It has been quite a long video series. There's lots of keying sequences that we learned and interpretation. And here we are finally at example 4, where we're going to discuss correlation and something else called causation. Okay? Now look above, there's some information I need to share with you. Causation refers to cause and effect. So basically what we're saying is, does our X actually cause the Y? Okay? And so I want to show you one example, and we're going to talk about what that causation in that example. So let me read the rest of it. If a change in one variable directly causes a change in the other variable, then there is a cause and effect relationship between the variables. It is possible to have correlation, to have a strong correlation, but no causation. Okay, now let me flip back in your packet, go back 2 pages to the example 3 correlation coefficient example we did in the previous video. And I want you to look at, and we're going to compare population versus the average commute time. We calculated that the correlation coefficient was 0.711, and we said that line of fit very well represents the data. It's a strongly positive correlation. But is there causation here? Does the amount of population affect the commute time? Well, let's talk about that. I think there's some validity here. The more people you have, the more cars you have, and the longer your wait time in traffic's going to be. So I would say that there's definitely causation here, that the more people there are, the more time your commute's going to be, because there's going to be more cars on the road. So this example, I think, shows both strong correlation and also indicates causation, that the population amount of people does affect the amount of time. Okay, now let's flip back to this example 4, and they give you a table. Here's the table. We don't have to put it in our calculator, so don't worry. This is totally just an assessment type of thing. The table shows test averages of 8 students. The equation of the least squares line for the data is y equals 0.77x plus 18.12. And they give us the correlation coefficient as 0.87. Okay, so wonderful news. You don't have to plug anything into your calculator. They gave you the line of best fit, also known as the least squares line, and they also gave you the correlation coefficient. So our job is to discuss, use words to describe the correlation and the causation for this data set where we're comparing U.S. history test averages for 8 kids and science test averages for those same 8 kids. Okay? So let's start with the correlation coefficient. What does that 0.87 tell you? Well, what it tells me is that there is a strong correlation. The higher that number, the closer that correlation coefficient is to 1, the stronger the correlation is. There's a strong correlation, okay? I can say that it is strong because of the number 0.87 being so close to 1, okay? So there's a strong correlation. Now let's talk about causation. This is how I do it. I look at the top line, U.S. history test average, and I treat that as though that would be the X, or my L1 in my calculator, and the science test average is my Y. Okay, so does what you make on a history test affect what you make on a science test? Does one have an effect on the other? Okay, so think about that for just a second, because some of you are trying to rationalize it. You may be overthinking this. Okay, so let me give you the short answer here. The answer is one does not cause the other. Okay, no causation. There is no causation. What you make on a history test does not affect what you make on a science test. So there's no causation in this particular example. Now, if they were comparing how much time was spent studying and how that affected test averages, then there would be some causation there. I think the more good, concentrated, quality time that's spent on studying, the higher the test scores will be. And of course, I'll give you my little speech about don't wait till the last minute to study, okay? It's always better to kind of spread that studying out. But we're not comparing those two. We're just comparing the U.S. history test average to the science test average. They have a strong correlation, but there's no causation. One does not cause the other. There's no cause and effect here. So I tried to show you 2 pages ago where there was a strong correlation. So this has a strong correlation and has causation. And the reason why I can justify that is because the more people there are, the more cars, which is going to affect the time and minutes that they're sitting in traffic. So definitely, if there's not a lot of traffic, you're going to get through to your destination a lot faster than if there's lots of traffic and you have to wait on cars to get through. Here, I'll try to show you an example where you may have strong correlation, but those two don't have any causation. History test average does not cause the science test average. Okay? Now, I hope that made sense. If it didn't, rewind me, listen to it one more time. And if you're still confused, let's come to class and have a discussion about it, okay? Thank you very much.